So after all this talk of groups and fields and things like that, where do vector spaces come in? Well, let's see. I'm going to scroll down here a little bit. So it turns out that a vector space is actually what we call a field acting on a group. So in other words, the vector space itself is going to be a group. And so if you think about this should jive with your intuition. So for instance, if you have like the vector space R2, you know that you can add any two elements of R2 together, etc., right? And so the vector space is going to be a group, and so let's just call it a group G. And the group G, actually, let me get rid of this for a moment. So the group G is going to be the set of, that's going to be your vectors. And so if we have two things, psi and phi, from here, then it needs to be the case that it's closed, right? So when I add them together, I get another thing back from the group. But then we also have at the same time a field. And the field, this is where we get our scalars. And so if A is a scalar and phi is an element of the group, so it's a vector, then it needs to be the case that somehow A times phi is an element of the group again. So now this is a little wonky from what we were looking at in the previous slides. So what we've got is we've got now an addition operation on the Cartesian product of G and G, but then we have a scalar multiplication. Oh, sorry, I just called that addition and wrote times. That's supposed to be plus there. Then we've got a multiplication operation that takes a scalar and a group element, and it spits out a group element. Okay, and so the upshot of all of this is that with this together, if we have scalars A and B, and we have vectors phi and psi, then we can do what's called taking a linear combination and that's going to be a vector again. So this here, this is a linear combination of those elements. And so a vector space is a set that is closed under linear combinations. And in particular where the set of vectors has a group structure and the set of scalars has a field structure. So we're going to go on into the next chapter, and I'll give you the definition of a vector space. And it's going to be this big, long, hairy list of like 10 or 12 bullet points that need to be satisfied. And basically, if you sort all of this out, those are just the individual bits and pieces for ensuring that the vector space is a group under addition, and that addition is commutative, and that also there's a scalar multiplication operation defined with scalars coming from a particular field.